So, hello everyone. So today we will discuss about the machine learning, and there's 5 to 6 questions which we solved uh, in today's session. So the first question is about the explain the difference between supervised and unsupervised machine learning algorithm. So, in supervised learning is a method in which we teach the machine using labeled data, whereas the in unsupervised learning the machine is trained on unlabeled data without any guidance, so that's why it should discover hidden patterns and trends in the data. Now the next parameter to consider is the type of problems that are solved using supervised and unsupervised learning. So under supervised learning, we have two main categories of problem. We have a regression problems and we have a classification problem. Where classification means is predicting about the class, and regression is about predicting a continuous quantity. Okay, now comes to the unsupervised learning. Coming to the unsupervised learning, it can be used to solve association problems and clustering problems. Association problems basically involve discovering patterns in data, finding co-occurrences, and so on. And unsupervised learning also handles clustering problems. The main aim or the main goal of the supervised machine learning algorithm is to forecast an outcome, whereas the unsupervised learning is all about the discovering patterns and extracting useful insights. Now, since the algorithm is only fed the input, it has to find a way to get to the output by finding trends and association in the data. So, second question is what is the difference between classification and regression? So, classification, as I told in the first question, is used when our target variable is categorical, while regression is used when our target variable is continuous. Both classification and regression belong to the category of supervised machine learning algorithm. So examples of the classification problems include like predicting yes or no, estimating gender, breed of an animal, or type of the color. Whereas the example of the regression problems include estimating sales and price of a product, predicting the amount of rainfall, predicting the score of a team. Okay. So now our question number three is how to ensure that our model is not overfitting. So there are multiple ways of avoiding overfitting, but first of all, we have to understand what is overfitting. So overfitting is a situation that occurs when a model learns the training set too well, taking up random fluctuations in the training data as concepts. This impact the model's ability to generalize and don't apply to new data. When our model is when a model is given the training data and it shows 100% accuracy, technically a slight loss, but when we use the test data, there may be an error and low efficiency. So this condition is known as overfitting. So there are multiple ways to avoid the overfitting, such as regularization, which involves a cost term for the features involved with the objective function, and second one is making a simple model with the lesser variables and parameters. The variance can be reduced. Then third one is cross validation methods like k-folds can also be used. And fourth one is if some model parameters are likely to cause overfitting, techniques for regularization lasso can be used that penalize these parameters. Question number four is what is mean by training set and testing set. So, training set is examples given to the model to analyze and learn, whereas the test set is used to test the accuracy of the hypothesis generated by the model. 70% of the total data is typically taken as a training data set, and remaining 30% is taken as testing data set. This is a label data used to train the model in training set, whereas the we test without label data and then verify results with labels. Okay, So this is training and testing set. Now the question number 5 is explain dimension reduction in machine learning. Okay, so in machine learning classification problems, there are often too many factors on the basis of which the final classification is done. These factors are basically variables called features. The higher the number of features, the harder it gets to visualize the training set and then work on it. Sometimes most of these features are correlated and hence redundant. This is where dimensionality reduction algorithm come into play. Dimensionality reduction is the process of reducing the number of random variables under consideration by obtaining a set of principal variables. It can be divided into feature selection and feature extraction. Now the last question is what should you do when your model is suffering from low bias and high variance? So answer of this question is low bias occurs when the model's predicted values are near to actual values. Okay, in other words, I can say the model becomes flexible enough to mimic the training data distribution. Okay, so while it sounds like great achievement, but not to forget, a flexible model has to generalization capabilities. It means when this model is tested on the unseen data, it gives disappointing results. Okay, so in such situation, what we can do, we can use bagging algorithm like random forest to tackle high variance problem. Bagging algorithm divides a data set into subset made with repeated randomizing sampling, and then these samples are used to generate a set of models using a single learning algorithm. Later, the model predictions are combined using voting, classification, or averaging like regression, also to combat high variance. What we can do, use regularization technique where higher model coefficients get penalized, hence lowering model complexity. And second one is use top and features from the variable importance chart. Maybe with all the variable in the data set, the algorithm is having difficulty in finding the meaningful signal. So that's how can uh, uh, we can do, like if our model is suffering from low bias and high variance. So this is the way uh, which we tackle uh, tackle the model. So thank you very much.